Welcome back to another session. We are continuing with projectiles. We managed to do the first two, which is throwing the ball downwards or releasing it, and we worked out the problems involving the two. And then now we are in the next scenario again, where now the ball is projected vertically upwards and return to the same level. What we need to know about this one is that first and foremost, we said that you need to choose direction. Our guide was that we are guided by initial velocity. Therefore, because I've got this one now, the initial velocity is upwards. The ball is projected vertically upwards. Therefore, initial velocity is up, then we'll take upward as positive. Yes, I hope it's clear. Now, if the object starts here, let's say for argument's sake, at 10 meters per second up. Now, at the highest point here, which is the turning point, before the ball can come down, it has to stop. Therefore, the final velocity on its way up will be 0. And then again, the initial velocity on its way down will be 0, this side. And the final velocity here on its way down before reaching the same level, it will be equivalent as the initial velocity with which the ball was thrown upwards, which this one will be negative 10 meters per second. If we interpret the 10, then it will be now 10 meters per second if we interpret the negative downwards. That is how it pans out in this one. What you should know about this scenario is that the time it takes for the ball to reach the maximum height here then is the same as the time it takes the ball to reach the same level, meaning that if the whole time is 4 seconds, meaning that the time from here to here will be 2 seconds, and the time from here to here will be 2 seconds again. So, or if we know the time from here to here is 3 seconds, therefore the ball was in air for 6 seconds. That's how we deal with this one. So the time it takes delta t upwards is the same as delta t downwards. So in this case, fine. All the same, we know that now throughout this motion, the projectile will be accelerating. Acceleration of the projectile will be 9.8 meters per second squared downwards. That is throughout the motion. Whether the projectile is at here, any point, whether it's at the top here and then going down, it will be accelerating at this one. But for calculation purposes, because we say this is always downwards, then for calculation purposes, that's when now if we choose upward as positive, it means that now this direction of A acceleration will be negative now. So that is when we calculate. Now let's take one example here. It says a ball is thrown. A ball is thrown vertically upwards, vertically up at 4 meters per second, 4 meters per second now, and returns back, returns to the thrower's hand, thrower's hand. First, they say in the questions, calculate, okay, calculate the following. Number 1, the maximum height reached by the ball here. And then the second one, calculate time taken for the ball to reach the highest point. Calculate the time taken to reach maximum height, maximum delta y. Number 3 will be also calculate the total time. That one relatively easier, as we said. And then the last one, they say calculate the total displacement. Also that one should be very easy. Displacement of the ball during the entire motion. Now let's try to work out. We say first and foremost we have to choose direction. We are guided by VI. Remember to write all the 5 quantities as a strategy here. That will make you to solve all these problems with ease. VI, VF, A, delta T, and then delta Y. So the VI now is upward. The stone is thrown vertically up, therefore I'll take upward as positive. Because A is downwards, therefore A will become now negative 9.8. And then VI is given according to the statement. It's said to be 4 meters per second. Fine. What else do we know? Remember we said the time it takes to reach the maximum height here is the same as the time it takes to reach the same level. Again, at the maximum height on its way up, the final velocity is 0. Thank you. Now we know at least 3. We can use equations of motion. We are remaining with only 2 to manipulate here. On this question, the first question, they say calculate the maximum height. If you read from the question here, calculate the maximum height reached by the ball. We are calculating delta y. So according to this one now, if we calculate delta y, meaning that in simple terms, we go for the formula with delta y, A, VF, VI. Or again, another approach can say we go for the formula that is without delta t. Without delta t. Therefore, there's only one formula in the 4 equations of motion that doesn't have delta t. Therefore, the easiest one, that's our number 1, we'll have VF squared equals to VI squared plus 2A delta y. That you just copy like that. The final velocity is 0. And then initial is 4 squared plus 2 into negative 9.8 multiplied by delta y. So if you use your calculator correctly, you will find that delta y will give us 0.82 meters. That is the height reached by the ball, 0.82 meters. Fine. Now the next question. The next question says calculate the time taken for the ball to reach maximum height. Calculate the time it takes. So now with this one, we are so fortunate. If you look at this, now we have got delta y now is found to be 0.82. Now if you have got 4 quantities, you can choose any formula with delta t in this case. Otherwise, you can stick to the original given values and go for the formula with delta t, A, VF, and VI. So that's the easiest one as well. So otherwise, you can use this, because even if it's wrong, you use it, then we're going to give you full marks for positive marking there, because the working of this one is done in the previous sub question. Now let's go for the easiest formula, which is the first one. VF equals to VI plus A delta t. Then we substitute. Final velocity is 0. Initial is 4. And then plus negative 9.8 delta t. Now if you work it out with your calculator, you will get that delta t equals to 0.41 seconds. That is the time it takes for the ball to reach the maximum height. Question number 3. So easy. to say to us, calculate the total time. We said that we know that the time it takes ball to reach maximum height is the same as the time it takes the ball to reach the same level where it was thrown up. Therefore, the total time in this case will be 2 times 0.41, which will be the same as 0.82 seconds. That is the total time. And then the last one, they say calculate the total displacement. Total displacement. Remember, displacement by definition is the straight line drawn from the starting point to the final point. In this case, now the ball is already returned to the same thrower's hand. Therefore, the displacement of the ball, delta y, would be 0 meters. So that will be the delta y for this question. Otherwise, you can expect another question of, say, draw a velocity time graph for this motion. So in this case, it was not asked. If it's asked, then the velocity time graph, remember in this case, then it should have two sides. This will be your velocity in meters per second, and then time, don't forget the units always in brackets in this case, and then 0 will be here. If we take upward as positive, we'll start from positive 10 and then finish at positive 4 and finish at negative 4. So we'll finish somewhere here at negative 4, and then we start at positive 4. Then the time that they ask us to say the time it takes to reach the maximum height, you have to mention that one. Remember, in the graph, if you are drawing a graph, please note of the values that you are asked to calculate. Those values must be used in this case. So this will be the case. If you want to include this one, no problem, can be 0.82. So this will be a velocity time graph, normally for 4 marks. So this one is when I choose upward as positive, as I was doing this one. If it's downward is positive, then it will be just almost the same, but now we'll have the positive slope. I hope we get the difference between the two. So until the next part of this projectile, so thanks for now.